So, so before we do this, let's look at A prime, A tilde and B tilde. So what are A tilde and B tilde? Do you have any questions so far?
No, sir.
Okay, so what are A tilde and B tilde? Okay, so it's very easy to solve because we know the values of uh, of L now, KL now. So if you plug that into, say, our boundary condition, we get that A tilde e to the power minus I n pi. So okay, n pi over 2 plus B tilde e to the power plus I n pi by 2 is 0, right? So this means that A tilde is equal to minus B tilde, and we multiply, both sides by, this factor. So this, this guy goes away, and this guy, just becomes square of this, and that is just e to the power I n of pi. But e to the power I n of pi is nothing but minus 1 to the power n, right? So we see that A tilde is related to B tilde by minus 1 to the power n B tilde. So we have two sets of linearly independent solutions, right? So we have two sets of linearly independent solutions. Is that clear why?
Exactly. I don't think I'm sure about that.
Okay, sure. So let me show you. So our solution was psi of 2 is A tilde e to the power I k of x plus B tilde e to the power minus k of x. Now the boundary conditions, all that they do is that they give you some quantization value of k. K gets replaced by kn, right? Because if I solve this condition, this for a given value of L, all that it is going to give us is that it's going to tell us that K can only take some discrete values, right? So, so that's all we get from here. But when we allow for the values of A and B, we see that, for n even, if n is even, we see that A tilde must be equal to minus B tilde. So for A even, I get psi 2 is A tilde e to the power I kx minus e to the power minus I kx, right? And for n odd, we find that because then A tilde and B tilde are equal, we find that the solution is e to the power I kx plus e to the power minus I kx. Now this is linearly independent from this guy. So if I add them, they will be linearly independent from subtracting them, right? So that's how we see that there are two classes of linearly independent solutions, one for n even, one for n odd. Okay?
I see. Yeah, got it.
Okay, good. So now we can plug in the values of, so the values of A exactly doesn't mean anything because we are going to be normalizing this. When we normalize this, the value of A tilde will get uniquely determined, right? So A tilde, the value of A tilde is not important, but let's look at, let's express this in sine and cosine functions. So for n even, this we find that this is a minus sign. So that means that psi of 2 is going to be A tilde times 2i sine of, now we can replace k by its values, which is n of pi over L times x. Okay. So for n even, this is what we get. So this is times. And for n odd, we find psi 2 is a tilde 2 cosine, right, of n of pi over L of x. Okay. Now, if I normalize this, so then, if I normalize this, normalize these, then we can find that a tilde is just given by square root of 2 over L, okay? All right, so now let's look at these, two functions. So n even, let's look at n even. So psi of 2, that is psi in the 2 region, is square root of 2 over L sine of n of pi L of x. So this is a function of x. Now, if I replace x by minus x, because sine is an odd function, I see that it's going to give me minus of psi of x, right? So we can also, let me just change the notation a little bit, and let me just denote the wave function in the region 2 just by psi, okay? And then we can denote the wave function, label each wave function by the integer n. So we see that for a given integer n, psi of x is equal to minus psi of minus x. Okay? But if you replace x by minus x, that is equivalent to on the left, replacing n by minus n, right? So, and similarly for n odd, we see the same thing. Psi of n of x is square root of L by 2. Oh, sorry, it's the other way around. Square root of 2 by L. And then we have, say, cosine of n pi L by x. And here, psi of n of minus x is equal to psi of n of x. And here we also see that x, you can replace x by minus x, is equivalent to changing n by minus n. So we conclude that without loss of generality, we can, okay, let me just say why. Remember that in quantum mechanics, two wave functions, psi and minus psi, are equivalent, right? In fact, two wave functions, psi and a constant times psi are equivalent. Remember that?
Yes, sir.
Yeah, so that means that if my wave function changes by a minus sign or it doesn't change by any sign, they're of course equivalent. That means that, without loss of generality, we can take n to be positive, okay? Because we see that n negative is proportional to the wave function for n negative, if n positive, right? So it cannot be a physically independent wave function. That is, so for example, you take the wave function for n equals 2 plus 5. You find that it is proportional to the wave function with n equals to minus 5, right? So that means these two wave functions should be equivalent. Therefore, we can take n to be just positive, okay? Oh, sorry, it's a mosquito. Okay, any questions about this?